Recording is on.
And now we're rolling.
Hi, everyone. My name is Melanie, and I'm going to be interviewing my friend JP. Hi, JP.
Hi.
Would you like to introduce yourself to the camera and also let us know what your job title and your company is?
Yeah, so my name is JP. I'm currently working as a software engineer at AI Solutions, which is a contractor for NASA Goddard Space Flight Center.
Cool. And how long have you been doing this career?
I'm coming up on around 5 years.
So, what did you think your career would be in high school?
Man, in high school, I wasn't really sure what I wanted to do. I think if I had known that maybe this job existed, I probably would have aimed more towards that. But I just knew that I liked science, I liked computers, I liked technology, and so I specifically kind of chose a school that was a little more broad to kind of give me a little more experience with a whole bunch of different things, so I could see what's out there. So I wasn't really sure what I was going to be doing, except that I was pretty sure that computer programming and would be involved in probably some math, and turns out I was right.
So, how would you say, I know this might be a tricky question, but how would you say your initial vision of your future career from when you were a student in middle school or high school is different from where you actually are today?
Yeah. It's interesting because, like I said, I didn't really know this kind of job existed when I was like in middle school and high school. I didn't, it seems kind of silly in retrospect, but just the idea of like, hey, what do engineers do day to day? Like, what kind of work is out there? It just never really occurred to me. But again, like I just thought, I liked computer programming, I liked doing math, I liked doing physics, and so I kind of just thought that, you know, might maybe I would end up working in something like programming video games or some sort of science field, but I really wasn't sure. I would say I think if I were to go back to myself in like ninth grade and say like, hey, this is what I'm doing now, I don't think I'd be super surprised. I'd be pretty excited, but I'd be like, yeah, that seems like about right.
So, for this next question, I know your personal answer is kind of unique to most people who are in your field, but how would you basically describe the pathway that brought you to your career today?
Yeah, so it's definitely a little bit different. I think most of the people I work with went to school for aerospace engineering, and they took a bunch of aerospace classes and learned about, orbital mechanics and all that kind of stuff. And I didn't. I kind of did a more broad uh, study where I majored in math and computer science again with the thinking that I like both these topics and they kind of apply to basically everything at some point. Um, and so I was working as a web developer. I was making websites, kind of like the back end stuff that makes all the websites kind of work behind the scenes. But I was still really interested in space, and I got more and more interested in space and started trying to figure out how to work on that. And wasn't again, so I just wasn't really sure how to crack into the industry. And what's funny is for a long time, it just never even occurred to me like to just apply to some of these places. It's like, oh no, I don't. I'm not. I don't know that stuff. They surely wouldn't accept me. And eventually, what happened was at a kind of a nerd convention, I was giving a presentation about how spaceflight in fiction differs from spaceflight in reality, just kind of talking about how the rockets work, how the orbits work. At the end of it, a guy came up to me and said that he worked at the Goddard Space Flight Center and wanted to talk to me, and basically encouraged me to look into it and said, you know math, you know computers, and you clearly care about space. Like, go start applying. And I did, and I got some jobs. And like, it's just, hey, it turns out that I could do this thing after all. And so ever since then, I've kind of come at from this other angle where I think a lot of the people I work with, they learned aerospace in school and learned computer programming kind of on the job. And I did it basically the other way. I learned a lot of computer programming in school and in my kind of first career. And then I've been learning space stuff, as I go. And so far it's worked out pretty well. And I've had a lot of really, great people who have been willing to teach me, it's kind of the hardcore math behind, how does a space shuttle know which way to go and that kind of stuff.
So, you mentioned that you kind of studied math and computer programming, while some of your colleagues maybe studied aerospace engineering or something like that.
Yeah.
So, what sort of education is like absolutely required for the position you hold? And what other sorts of trainings are more of those like optional pieces?
Yeah, so I think specifically for the kind of role that I'm doing, which is, my actual current task is I'm writing, computer systems to help plan how the spacecraft is going to move. So
Mm-hmm.
it's a lot of computer programming, and understanding the math helps a lot because it gives you the context of like what you're really trying to do. So I'd say for like if you were, for instance, going to be joining my team, like what I'd be looking for is like absolutely you need to know how to program computers. That's guaranteed. Whether it's some of the popular languages are Python, or MATLAB is pretty popular in the aerospace world. It's not super important which language, so much as you've learned a language,
Right.
and knowing, depending on if you want to focus on computer stuff, that's probably good enough right there. But also, if you want to be kind of like what I'm trying to do, which is get more and more into mission analysis and like kind of really planning what the spacecraft should do rather than telling computers how to figure that out, you need to get a lot into the math background. One thing that really kind of surprised me is, it's really how much stuff I did in like English classes really paid off. Like, it's communication is really critical, and to be honest, there's a lot of people who are really smart and really know their stuff who just can't communicate very well. And it's the kind of thing where I had this moment of like, oh man, like this is literally like some my assignments where it's like, hey, go learn all about this thing and make a slideshow and tell the group like, what's the deal with this? Because we don't have time to go spend a week learning it. So you're going to do that and you're going to tell us in an hour. And, it being able to kind of figure out how to, pull out the most relevant parts of something, how to present that in a way that everyone in the room is going to understand and kind of come at it from different angles. So if you don't catch them in one time, you're going to get it in a different way. It's, I think I've been pretty good at that, and it's really, really served me well. I think, just because I can get my ideas across, and if you can't get your ideas across, no one can really judge if they're good or not. So, it helps to have. So I guess it helped to have the computer background, less so the math background for my particular role. But there's absolutely a lot of math to be had at NASA, and communication is really, if you can communicate well, you will do really well.
I'm really glad that you said that too.
Yeah.
Um, so, could you just give us like a brief description of what your specific branch, your specific team does as far as both your company and for NASA itself? Because I know when it comes to like AI versus NASA, there's some intricacies that are a little more specific that the average viewer to this video might not be aware of.
Yeah, and that's actually been something really fascinating, is learning like how the day-to-day business of space stuff gets done, because it's very specialized. Like for instance, I wouldn't be able to tell you much about really nitty-gritty of how rocket engines work, because rocket engines tend to be handled by NASA Marshall Space Flight Center down in Alabama. And for instance, I don't our area doesn't really work on stuff like Mars or Saturn. That tends to be the Jet Propulsion Laboratory out in California. So NASA Goddard tends to focus on solar physics and Earth physics. So like a lot of like a lot of this is like when you hear news stories about, oh, this big chunk of ice came off the ice caps and is drifting away. Well, the reason we know that is because we've got satellites that are watching it. Um, and even special bringing it down that level, there's still a lot of other specialties. For instance, when you have a satellite, you got to have people who know how to build it. You got to have people who know how heat is going to propagate through it. You got to know people who can power it. You got to have again, it's going to have its own little rocket engines for getting around. The specific thing that AI solutions generally kind of focuses on is flight dynamics, which is where were we, where are we, where are we going, and how do we get to where we want to be. And you can kind of think of it as the driver of the spacecraft. And so what I've been doing is I work on a mission called OSAM-1, which is going to be trying to go up and rendezvous, meet up with another spacecraft, grab onto it with a robot arm, and try to refuel it, which is not something that it was built to do. So it's going to be a little bit interesting. They're going to have to like cut it open, and all sorts of interesting robotic stuff. There's another one, robotics. There's a lot of robotics people, and so in order to do that, you have to do all sorts of flight dynamics things. Like, how do you get this? So we're going to start off on a launch pad in California or Florida at 0 miles an hour. Okay, well, in not too long after that, we need to be going 17,500 miles an hour right behind Landsat 7 and at the same position and the same velocity so we don't crash into it. How do you do that? And you know, you've got some of the more math heavy people are kind of figuring out the general approach, and then my team is writing the ground systems to actually do that. So the day to day of, like, let's say we're a week into the mission, we've been up there for a little bit, and we're going to get fresh information from radar information from where we are, and it's got GPS on board, so we factor that in to update. Now we know where it is, and hey, we're a little bit different from where we thought we were, so let's replan all of our maneuvers that are coming up so that we can get to the spacecraft. And it's a lot of just kind of like breaking down the problem, breaking down the problem, breaking down the problem until you get all the way down to the point where all the problems are manageable. And then you kind of start reassembling them all back up. And at the end of the day, you've grabbed Landsat 7 and refueled it.
And so, what are your specific duties within your position on that project?
Yeah, so I'm the team lead for the flight dynamics ground system. So what I've been doing is I've got a couple people on the team where I have to kind of know their strengths and weaknesses and like what they're interested in and figure out like what they're going to be working on for the next 2 weeks. We work in these 2 week cycles. We kind of look at what work has to come up and break problems down to these 2 week kind of 2 week long problems. And so I work a lot with figuring out what they should be working on, helping if they run into any problems, reviewing their code, and they end up reviewing my code. And so when I'm not kind of splitting up those problems, I'm writing computer code to work on these systems. I'm writing specialized code that's going to target a maneuver, like figure out how the what the rocket in the back of the satellite should do, or simple stuff like, hey, we need to, we're going to be getting these files, and we need to get these files to another team. How do we do that? And we need to make a file that another team needs to read with their computer. So let's make up a bunch of really detailed rules for how that's going to work, so that everything can mesh together. So it's a lot of communicating with other teams, communicating with people on my team, keeping people on other teams in the loop of what's happening, and making sure we're all kind of on the same page. And then also working on the actual code and actually getting some stuff written so that the satellite can work at the end of the day.
And what kind of tools or technology or equipment do you use to kind of do those daily tasks?
Yeah, so a central one is actually a piece of software that my company makes called FreeFlyer, and it's basically a specialized piece of software that's dedicated to this specific type of problem. It's got its own little programming language, and it's got a lot of kind of tools that make it easier. Like, for instance, it might you might want to say, well, how fast is this satellite going relative to another satellite? Okay, how fast is it going relative to the Earth? How fast is it going relative to the Moon or something? And you could write all that code yourself, but it'd be kind of a hassle, and it's been solved for decades. So FreeFlyer kind of bundles all that up together. We use the programming language Python to kind of help kind of basically kind of move things around between other systems. It's called a glue language. We're using a little bit of web programming to make a nice user interface for people to use during operations. Um, you know, and then as far as the other stuff, we use just good old Microsoft Teams to communicate within the team. We use Microsoft Outlook for just email. So much email. There's a lot of email. NASA's all about email. NASA's really also about Microsoft products, which kind of caught me off guard. There's a lot, there's a lot of PowerPoint, a lot of Excel, and a lot of editing. Like learn how to use all the little formatting tricks in Word. Uh, but yeah, and then some kind of specialized computer programming tools. Like I like Vim a lot, which makes me the weird one on the team. But I'll forever defend Vim. Learn Vim. You won't regret it. Probably. Maybe.
Okay. So, what would you say you like and also dislike about your current position?
Yeah, I really like feeling like I really like working on a mission that there's a lot of work you can do that doesn't directly impact a specific mission. It might just be kind of general analysis work or like making some general tools that maybe get used on a mission someday. I like knowing that like this, I'll put it this way, a tool that I wrote that, I wrote it by consulting with a lot of people who, know the math better and like, a lot of smart people to work together. But at the end of the day, I wrote this tool that will calculate some numbers, and we'll use those numbers to tell either SpaceX or ULA, hey, please put the rocket here. And it's like, I'm telling the rocket where to go? That's pretty rad. I'll take that. So that kind of stuff is really really cool, and also just like moments where I previously worked on three other satellites that are already in orbit, and at the right time of year, I can walk outside and see them fly by. I'm like, oh, I know them. I know those three. Um, the less fun stuff, it's still a job. There's a lot of answering emails and writing status reports, and a lot of just kind of like slogging through a lot of documentation where, again, it's really, really important that not only do you know what you're doing, but your team knows what you're doing, and like adjacent teams know what they're doing, and also people who might be interacting with your software 4 years from now, when maybe you're not even, maybe you're on a new project by then, like you have to make sure everyone understands what's happening and why and be on the same page. So there's a lot of writing documentation in a very clear way. You really got to communicate, and that kind of stuff tends to be a little bit different from like presentations. It's more technical of like make sure you're being precise and that you're not leaving any loopholes, and there's no way to like misinterpret stuff. Um, so there's the kind of like that project management aspect, that kind of technical, sometimes called technical debt, kind of the stuff around the edges that you could slack on, but it's just you're gonna have to do it one way or another eventually. And then there's kind of the really fun stuff, which is writing the code, seeing the simulations go, and then eventually, seeing your stuff fly.
So I know we're still kind of living through this unusual time where everyone's still mostly working from home.
Yeah.
But could you do a little bit to describe what your workspace setting was like before quarantine began, and then maybe speak a little bit about how workflow has changed since this has happened?
Yeah, so I'll say before I was on the previous mission, I worked out of AI's headquarters, which is about 10 minutes down the road from Goddard. And this was kind of like a typical kind of open office design. Everyone had little desks in a big open area with, if you've ever seen like pictures of Facebook headquarters, it's not dissimilar to that. A lot of companies try to have that kind of cool image. Um, but,
I don't think I've ever seen those pictures, but I'm sure anyone watching this video could Google it if they wanted to see it.
basically just imagine a warehouse full of desks, and every desk has a bunch of monitors on it, and there's no walls or anything because it's cool and supposed to facilitate communication. And some people who got to focus really hard tend to get a little bit annoyed that there's noise, but you wear your head I would wear my headphones all day listening to music and working on my stuff. When I moved over to Goddard's a little bit different because the government, a private company can say, "Hey, we're going to spend this money making like getting like nice desks and painting the walls red and doing what we think is cool." The government has to justify that kind of stuff. It's your tax dollars, so stuff tends to be a lot more functional. And so, my where I worked, I was lucky enough to be on the mission early enough that I shared an office with one other person, so I basically almost had my own office, but it was like wedged in a back room of the basement. And it wasn't like you know a, it was a finished basement. It was nice that I had like there's like a pretty decent desk computer set up with a couple monitors and everything, but it was also like there was no window, and it was that would get kind of old. Or I'd come upstairs at the end of the day and be like, oh my god, it's raining. Like I had no idea. But what's cool about that is if I ever got like frustrated by not having a window, or be like oh, I've been down in this basement too long, I could just go upstairs because this was the building where they control the Hubble Space Telescope. So I could just go wander around upstairs, and there's at the end of the day, it's just kind of people sitting around on their computers, but it's like you could see like a big scale mock-up of the Hubble and see people, you catch a peek of a slideshow where they're working some problem, or like, it's like that makes this job a little unique. I'm just like, man, that's wild that I could just go upstairs and there's the Hubble people.
Right. So this is an interesting question. Would you say you work mostly with people, things, or ideas?
I mean, as far as things, it's literally, if we're taking the most literal level, it's I laptop all the time. I'd say it's probably more people and ideas, but that very much meshes back and forth. It's like everything about everything about a space mission is like formulating one big idea and making sure that works and everything works together. Because the last thing you want to do is be 3 years into building your spacecraft and find out that, oh, this team thought that this screw goes over here and this other team thought it goes over here, and now we have to redesign everything, and you've made very expensive custom hardware and it's going to take a long time to undo everything. um, and also on the software side, it's a little bit even less tangible, where you have to have these systems that all kind of exist in your head in a way all play by the rules and work together. And so, but at the same time, to do that, you have to interact with a lot of people to make sure everyone's kind of doing the thing they need to do and everyone's got the information they need. And you want to avoid stuff like, if there's some aspect of your program that only your team knows, that's not great because some other team might make an assumption not knowing your need. Like, oh, it turns out, I'll just make up an example. Let's say that our team needed to get GPS data from the spacecraft. And we didn't tell anybody that. Well, there might not be a way to get that information to us, and then by the time we tell them we need it, it might be too late, and we have to come up with a different plan around that. So it's a lot of kind of this, a comparison might be keeping a bunch of plates spinning. If you've ever seen people do that, where they have a plate spinning on a pole, and they put another one plate on, and they set up another one, they're running around. And as long as you keep tapping each plate, keeping it spinning, they'll all be there stable. And so it's a bunch of people running around, keeping a bunch of different plates spinning. And I guess the plates are the ideas in this strange analogy, but that's what I'm going with.
I like it. So if you were going to hire someone to work for you or with you in the same sort of capacity that you're currently working,
Yeah.
what qualities would you look for in that potential hiree?
Right. I mean, if I'm, stuff I literally look for is I want to see that they got some sort of programming experience. Again, I don't really care too much what language. I don't really care what the application was. It's a certain way of thinking that's important to know that you can do that. If it's in a language that we're using, if it's a application that we're doing, that's great. That's bonus. But like, it's really just kind of important that you have that logical way of thinking. I want to see, just for contractual reasons, that you've got a certain degree. A lot of these jobs require like at least a bachelor's degree education in whatever your field is. Um, Something that I also look for is like, can they communicate their ideas well? I'll ask them stuff like, can you talk about a really complicated problem you worked on in your previous job? And the ones that have that spark that just launch right into it and can tell you everything about this technology stack, top to bottom, and why this was a problem and how they fixed it, that's always a really good sign. And this is, it's saying it. It's the way I say it is kind of a joke, but like it's totally true that you can kind of teach someone anything, but you can't teach them to give a crap. You got to see people who care, and you can tell that they care, and they aren't just there to proverbially punch the time card. Like there are roles for that, and I don't really necessarily hold anything against people who want to have that kind of career. Your career doesn't have to be your life, but it's like if you're going to be on this kind of team working on these kind of ideas, it's really important that you have some interest in it and you really genuinely are willing to like think hard about it and put your best effort into it and learn and grow. And if not, it's really difficult to work with because we're always getting new ideas, we're always getting exposed to new systems and new requirements and new languages like programming languages, and you have to just part of the job is figure it out and do it. And it can't be like, oh well, I didn't get trained in this. Like, great, neither did I. Do it. So like that kind of adaptability and caring.
I think that's such an important point too. I mean, for you, working at NASA and working with space, I know because we're friends that that's something that you've been passionate about even before you had this job. And luckily, with something like NASA and space, that's something that a lot of people would likely have a passion for coming to an interview. But just in general, as advice, I think finding the thing that you're really passionate about is just a great career advice because you're right. People who are doing the hiring can kind of tell whether you care about that topic or not when they're talking to you.
Yeah, and actually, there's an interesting point there. A funny thing about NASA is it's kind of inherently interesting, but uh, I've worked jobs that weren't NASA. I worked at a company in Buffalo, New York, that made portals for like web portals. So the way I kind of describe it is if you've ever had like the default Verizon homepage with the news and stuff on it, like we made the tools that made those, and we made them for a whole bunch of different cable companies, and it couldn't have been a more boring product. Like who cares? But in order to do that, there was a lot of technical challenges. So I worked on the team that made the tools that allowed people to post news about Lady Gaga or whatever. And like, we didn't really care how it got used. We cared how the people using it were, were they able to do their job? What problems were they running into? Was it working reliably? Did it break at 2 in the morning and we had to get a phone call? And that was really, really interesting. So I think that you'll find that with a lot of jobs where the end product maybe you're not super passionate about, but that might be okay because, if especially the kind of stuff that like computer programming and math gets into, it's a lot of puzzle solving, and you can find puzzles in a lot of boring things where the puzzles themselves are interesting. So, always keep a lookout for that.
So, with this very last piece of the interview, we'd really love to know what sort of kind of core classes, the classes that you kind of had to go through in middle school and high school, like English, social studies, math, foreign language. How do those actually come into practical application in your current work?
Yeah. So English, you know, English was good because it taught me again how to get my ideas across to other people, but also how to read something and get figure out what's going on with it. And I think it's a little bit different with like literary fiction and stuff, but like a lot of it's just like kind of reading comprehension of like you know fig- getting those ideas in your brain is critical in this kind of a job. So I think that's really served me well. Math, obviously, if anything, I wish I took more math and did better at it. And I was a math major, so yeah, that's not going to be every job, but man, I wish I knew calculus better to this day. So yeah, you will use it, maybe some of you. If your school offers computer programming, I really think that not every job's going to need that, but it's one of these things where no matter what you're interested in, if you can bring computer programming to the table there, you could find a role in a lot of different things. Everything from space to finance to management to let's say you like animals. I'm sure there's people who want to need to track wildlife and like model their movements and like how the populations are doing, and they're going to need people who can program that information into it and like know how to handle that stuff better. So definitely the computer programming stuff served me well. Foreign languages, it didn't come into my day-to-day life, but that's just kind of a particular to me. And I did enjoy those classes, and I'd say I took Latin, so I guess day-to-day life is I have a good chance of understanding what a word I don't know means just by looking at the root. Um, Social studies, it's been helpful to know knowing history is one of these things I think is really underrated. I really loved history in school. I listened to a lot of history podcasts, and just like knowing you kind of see stuff happening today where it's like, oh, that's a lot like this, and like it's kind of this shortcut for knowing how things will play out. And, not exactly, but you can see like, oh, this is similar to this bad thing that happened 200 years ago. I should this be careful about this, or like, hey, this idea being proposed by Congress, they tried that 100 years ago in France and it really worked out, and like, yeah, like I'm on board with that. It kind of lets you not have to figure everything out yourself because people have tried it. Um, so yeah, I mean, I really think you know I wasn't always the biggest fan of all of my classes all the time, but they really did serve me well. And looking back, really, I think I'd struggle to think of something that wasn't useful at some point. So
So if you kind of take a moment to reflect back on, the sort of student that you were when you were in, again, middle school and high school, and just kind of how you thought about school then, and then reflect on where you are now, how would you answer that kind of age-old question students have of why should I care about all this stuff?
yeah, so actually, I was thinking about this recently. It's interesting. To me, I never really thought about getting something out of school. It was like I went to school because that was the thing that I did. Ever since I could, like every little kid, you get up, you go to school. Why? Because your parents tell you to do it, and you got to do your assignments because your teachers tell you to do it. I never really thought about it for a long time. It was just kind of like I thought it was kind of interesting, and I'd work on it. And the idea of like, hey, you're spending your time here, your valuable time, and like there's like gold to be had if you dig for it a little bit. Like it's if I could go back, I would tell myself, and it's almost cliche, but like to apply myself more because in middle school and high school, I did fine, but like I could have done better, and it was more like I viewed school less like an opportunity to like get a lot of really cool information and more like a game to get past. It's like, oh well, I know I did really well on this test and I don't feel like reading this other thing, so I just won't do it because I've got the grade to coast by. And that was a really bad attitude. And I missed out on a lot of cool stuff because of that, and I think it compounds over time. Especially in the math side. If I want to learn about Lagrangians and Hamiltonian dynamics, I needed to have a really solid footing in calculus and the chain rule, and I never learned it that well because I kind of didn't. Again, I did. It was just a thing that I did. So I would say that like if you're listening to me now, like look at your class as if it's a product and you bought this product, you want to get something out of it. You bought it with your time, and you should you're you should get something out of it. Be present mentally and physically.
That's really good advice. And in general, I really appreciate you taking this time to share all of this really awesome information and wonderful advice with all of us. But that is the end of the questions I have for you. Do you have any sort of final thoughts for us as we say goodbye?
Space is cool. Keep up to date on space. Study math. Come apply. Work on the team.
All right. Well, thank you so much for your time. Have a great evening.
Yep. See ya.